Welcome to my little discussion today in regards to high-level technologies for rural villages in the Philippines. And I'm really glad you guys showed up here. It's really kind of a nice thing. So my name is Tito Young, and I have been involved in a series of different situations where it brought me to you guys today. And I think it's going to be kind of neat. We're going to be able to talk here. There's a history and background to what I do. I'm part of a team of people who work with robots. We make little service robots that we do our very best in trying to bring to the general public. And these robots actually use much of the big data informations that you guys have been seeing today. And these big data informations is becoming more and more as a standard in what we're looking at. And what I'm kind of hoping to do is to inspire you guys to move into the future, kind of think a little past the box that's been shown in front of us. And I'm glad you guys are here, because what we're going to try to attempt to do is to try to bring something I think is really wonderful. I'm also part of another group called Enhance a Village. And we're a 501(c) nonprofit. And we have a lot of professionals on our teams. There's writers and tech persons, and we deal a lot with like the IoT stuff. You can see over on the right side the robots that we use here. The robot uses telepresence, it uses speech recognition, facial recognition, data information that people pull out. All this stuff is all big data stuff. It is all requiring to move very, very fast. And there's a tie-in for different kinds of relationships that these robots are going to be able to pull in. So let's talk a little bit about the rural areas. And what happens is there's a lot of impoverished populations, and they have some challenges. They got challenges that require them to have food and water, shelter, and they are basically empty, unlike what cities might do. And we want to balance this out. We want to balance some of this technology out. We want to be able to bring some of this technology that we have in the cities, where we have these shared infrastructures and these shared technologies, and bring them into these villages that just have next to nothing. And what I was kind of inspiring all of us in these high-level technology worlds is to actually set this up. So let's get started. So I have a basic image here, just basically shows data collection where you have SQL engines, and you basically have something that's been really important. And I think all you guys understand the differences between the traditional disks databases and the IMDb, which is a version of what we're playing with today. But what I wanted to make very, very clear is that these villages are extremely intense. People don't live there because of their rurality and the fact that they're in the middle of nowhere and they have very little access to anything. There's a tendency that they hit all the bad weather. They have the worst deliveries. They have a lot of theft. Everything becomes very, very expensive. And what this technology that we're kind of establishing now just basically shows that we can make things faster and cheaper and far more durable. So something I found kind of interesting is that, and some of the other speakers were bringing this up earlier today, is that these IoTs are informations that we use. I mean, there's going to be monitoring devices and managing devices, and these devices that control itself to satellite. And what's really interesting is that I show this image where I have crop monitoring, I have livestock monitoring, water, and basically, crops, and I guess equipment, and I guess we even have different kinds of manufacturers that have IoT built in their equipment, so they can keep track and going up and down and making this farming as easy as possible. But how does this work in a village? How does this work in a rural area? Well, one of the ways is that these remote collection devices, and they're starting to actually appear in these rural villages where they're actually tying on certain kinds of devices. And some of them are independent to the systems that are out there, and some of them are actually, they actually have a connection to them directly to some kind of Wi-Fi device or some kind of satellite device. They measure solar and physical temperature. They can measure wind. They can measure voltage. And in fact, they can even measure wandering animals. And you kind of think about like how important that is, how important it is to have these kind of connections be this strong for such an area when your livelihood is based on one single animal. And if it should get lost, or you got 10 animals and you lose 2 of them, you're losing 20% of your livelihood. It could, in fact, be very much life and death, or the energy that it would take to go find an animal down some area. And it did not come clear to me till I actually was there. So here I show a slide of basically everything from politics to accessibility issues to manpower, everything to covers weather sensors and water level sensors, and all this stuff gets beamed back and forth to a satellite, and then basically the web, and basically this area that we're talking about, which is this real-time data. What we're doing here, it lives in all of that, in all that information, and all that code writing that is being produced by in fact this big data stuff is highly important, because like if this data gets lost, if this data disappears, or has some kind of weird redundancy issues or something like this, that it's life or death to basically these people. The investments are really high. So I was kind of breaking down a little bit, and you guys all know this sort of stuff, but I will run through a bit of it, is that this amount of information that's being brought down is broken up into a series of different resolutions. And the 3 different kinds of resolutions that I'm using here is, of course, is the spatial, and of course the temporal, and the the spectral, and the spectral. And the resolutions are also really important. So the higher resolutions that you have, the nearer you want to be, the smaller areas that you want to cover, and the larger areas, the more blurrier it would be. And what's really important is that not so much the resolution that you're looking at, but just how much this information really matters and how much it really says. So what is your information that you're being collected is also another aspect of what these rural villages see and not see. So I broke out a couple slides that again describes maybe what we would see in, maybe if you were using film, you could have black and white film, or you could have color film, and you could break down the different kinds of wavelengths that this stuff picks up, and sometimes you can use infrared to measure heat. And of course we have a digital version, which is a higher resolution, and here you could pick up things like water depth, coral, you could pick up tundra. In some things that these villagers are doing is that they're messing with the mangrove trees, they're messing with the fish, they're messing with the pollution, and these spectral resolutions are really important to be able to pick this out. And it'd be really nice that these higher resolutions that we're seeing and this data that we're seeing is being carried off. So you're kind of seeing slowly where I'm getting at. Of course, we have this temporal resolution too, which is this temporal scale. And this is another thing that a lot of people use, and whether it's EPA related or whether it's some kind of relationship to our way we want to view how we're going to use this information. Does the information apply to a scale that has to do with something really instantaneous, or is it going to be something that's local, or is it going to be something that's more in a global level further down line? And you could see that I made a representation on products and trade and showing how that's different than like rapid ecosystems and stuff like that we could have in front of us. In this example, I show a temporal scale being used in a small village in India, a place called Bathilia. And this is really kind of neat because it it gives you a lot of bit of information, like as far as you look at this green, you can see that there's a high level of vegetation where this green is. I mean, you can clearly see the rivers, you can clearly see the red, which might be nothing can grow there because it's a bunch of rocks, or maybe it's used for a different purpose. But I wanted to make something really, really clear. They don't have BART, they don't have trains, they walk. They walk, they ride a buggy, they hike. And I don't know if any of you ever carried a gallon of water for very far, but it's heavy. And so it's critical that this bit of information that they do have is something that they can really use and something that we could really save in the future. Of course, there's also the variations in remote sensing, and I know you guys are all about this, and this is what you guys do, but what I wanted to discuss here was, like, we now are starting to bring more and more images from drones and smaller airplane devices. I had a conversation with a guy who used a small one prop airplane. He had a large, I think it was like a 300-pound camera that was under it. He would basically fly this thing 4 times a year and basically look at the changes of vegetations that would happen. And of course, satellites would do similar things. Of course, they would, from a higher level and grab those. And I think I show an example of like how that happens up ahead. And in this image, I know we understand the remote sensing, but what happens is we have a passive remote sensing and we have an active remote sensing. And the passive one is something that goes into some kind of condition or some kind of system and gives you an output because it has a variation in voltage. It might have a variation and the variation in voltage might be salination in water. It could be something temperature-wise. It could be something that actually gives a change in readout. Again, this is really, really critical because this information that is collected is important to see over a period of time and not a one-time basis. So it's like, as these systems are being designed, think of them like what we're looking at in the future. What does this information tell us a year from now or 10 years from now in that temporal scale? And I have shown an example of what would happen in a remote active sensing where you could see infrared using like maybe on the bottom of some kind of radio device or some kind of like drone, and it reflects and the reflection hits the receiver. It's interesting too because in some of these areas there's a lot of clouds, there's a lot of tree coverages, there's a lot of tundra, there's a lot of material, there's a lot of everything that goes on there. So what are you actually reading if you can? So we want the systems to be able to pick that up. And I wanted to also talk about how the analysis and the processing of this stuff is, because that's basically what we're doing here, and why that works and how that works for our villages and what we're doing here. So if we look at key things like hybrids, like the amount of tools, the amount of supplies, the amount of predictions, the amount of statistics, and we're able to kind of put it in some kind of manner where decisions could be made. It's a life and death situation for these places. It really depends on where they're going with all of this. And here's an example of, like, I have these slides of these different kind of satellites that read out different levels of areas that they cover to the amount of information that they give them. Some of these probably aren't even around anymore, but they're definitely looking at us. The thing about these satellites is that when you get to remote areas, places in Africa, places outside the Philippines, places in northern tundras of of Russia, places like that, there aren't as many as there are here. And so it's kind of important to remember that, to keep those as a key issue. They do cover lots of bits of land when they do, and they do work when they want them to, but is it going to be around here? And these satellites give you two basic parts of information. One part of it is nature. It's the natural aspect of it, and the other part of it is man-made aspect of it. These are two real critical pieces of information. We have Political issues, we got boundary lines. I mean, these are lands that might have been raped and taken years and years and years ago by landowners that have them, and they're doing nothing with these lands. They're owned politically, there's these issues. And can this data, can all this big data be able to show that in layers? Can it show archaeological stuff? Can it show historical stuff? Can it show confidential layers? And then, of course, there's the natural part of it that show contours, rivers, trees, all the other things that go with it. Medicinal plants, that's really big. I mean, a lot of things are happening right now are on the medicinal level. And then, of course, the changes with the wildlife that can happen in these different areas. So we have this case of point of the Philippines. You can kind of see kind of what people do. And then this is probably built without much planning. Just go out there, stake out a piece of land, stake out a piece of natural area, and just start cutting it up. And you basically sit on it. I mean, you're squatters. You're not necessarily following any kind of rules. Government doesn't know this is going on. Local people don't really know this is going on. And there's a lot of issues that are happening here. And these rural villages are running into exactly that. And so as these bits of information are being collected, the question is how much of it could be right. And this is actually a very interesting aspect because A, the populations are really small over there, so there's no enforcement. And whatever enforcement might be by people who have no knowledge of enforcement or even of the land itself. There's also another thing that these small towns rely on, and that's the larger towns. And you think like, oh well, geez, they got larger towns to mess with. They got larger towns to figure out their waterways and to buy their products and sell their products and stuff like that. Well, that's not exactly always so. Sometimes these larger towns really take advantage of these smaller towns, take advantage of the people, take advantage of the equipment, take advantage of the labor, and sometimes farmers find themselves growing things that don't get sold or can't even be taken to their particular lands. And so it's important that we kind of get track of those things. So here I work with, I happen to work with the Vice President of the Philippines, Lenny Robrado. I actually work with Enhance a Village, and I work with some for-profit involvement, and this robot company I'm involved with is listening to me a little bit. But what's really interesting is that more than just products of like coconuts and sugar cane and and livestock, and more than just the endangered trees that happen and the endangered coral reefs, is that we've got guys like this guy here, his name is Boy, who is an artist, and when I was a little bit exposed to that, these guys produce really amazing art. They make art, they make boats, they make different kinds of clothing. Can our devices be able to capture layers that include human interaction and human changes that go with it? Can it pick up social values and be able to record that? Is there maybe factors that maybe we ought to think about with our equipment that we're building for this stuff that could actually have this sort of stuff? And to even bring it a little bit further, is that we're not talking about houses out here, we're talking about shacks and huts. I mean, these are shacks and huts that are demolished after monsoons or after windy storms or something like this. And they're connected by trails, basically unrecorded and changed yearly. It makes it really difficult. And with rising oceans, it's going to be another whole other can of worms we've got to deal with. Some of the areas are so rolling with terrain that you look at the information, you can't really tell how really tough it is to be inside those. So that's another thing that maybe as our big data is going to be coming in, do we think about like this sort of stuff? Do we think about this and how really rough it might be for a human? So my stand is to kind of come up with a way to optimize our production, handle the infrastructure, workforce, maybe work on libraries, capitalize on some of the housing that might be for some of these people. Can we bring technology to give survival an edge with our technology today? And I'm not talking about bringing them old stuff because it's cheap, but by bringing them new stuff because it's cheap. Here in this example, I show trends where information might give you farming yields, and this is really critical as well. Farming yields, of course, is like a big difference. If you can only make so many papayas a year and you can only grow them, how much can you produce on a piece of land? What would it cost you? What is the environmental impact? What's the waste? What do you do with the waste? Where does it go? Where does it land? What happens to it? So this information also can be very, very heavy. I talk about labor and tools and materials as well. And of course, one always thinks of like aquaponics and fish ponds and recirculating aquaculture systems where you have saltwater and freshwater tanks. And this is kind of a neat solution. You got all these really cool off-the-grid hippies that go out there and build this sort of stuff. And I think it's wonderful because they are in fact thinking out of the box, and they're thinking about taking things to make them work. For those that would want to know a little bit more about this, it's basically collecting fish waste, uses as fertilizer. Down in the lower corner, it's you get nutrifying bacteria from the fish waste to actually, the plants love this stuff, makes them grow faster. And it gets pumped by maybe a solar energy pump. And these informations could be IoT collected too as well. And this may be one sample of like what these guys were showing up a little earlier. But I think this is really wonderful because now all of a sudden we have a purpose, a really deep purpose that might make a difference in people's lives. You get to grow fish and you get to grow food and these people get to survive, and maybe if you're lucky, they're not going in and destroying the earth unintentionally because they're trying to survive off of it. There are some interesting issues that I had learned too when I was there. One of the issues has to do with the fact that the coconut trees themselves don't become effective when they get to be a certain height. Nobody wants to climb a 75-foot coconut tree without protection. They might climb a 55-foot one, but they won't climb a 75-foot one. So it's kind of good that maybe our IoTs could actually be able to regulate these kind of situations. And I'm talking about not just coconut. I'm talking about density of sugar cane or the amount of animals or whether locusts go in and wipe out. These are real life issues. And I'm talking about a deep level of understanding what these lands actually do. Often we here in the States and basically in our world, we look at greenhouses and we look at those kind of solutions. I mean, can we think about greenhouses maybe some kind of form of greenhouse that might work in those areas where we can actually control this amount of stuff and maybe work on some GMOs and some good GMOs. There's always the Monsanto bad ones, I guess, but. The other idea, too, that I was trying to bring up, too, is the insects. Insects are really important. We're having a new issue with bees that are a big issue that, the pollination stuff that's going on. We're having a really big issue with what happens in the soil with certain kinds of bugs and stuff, and little by little, the materials that are going in are kind of hurting them. I also had brought up the distillation idea as well, and distillation would be really a great way to grab that. So what we're trying to think about here is like this information that you guys are working on, and as I hope it goes up into your chain, is to work with these different kinds of nonprofits, and maybe the nonprofits that we have advisors and awareness groups, and how can we tell them what we find? How are these findings actually something useful that we can actually use? How can we improve expectations and at the same time give as much as we can without actually making it so expensive? A lot of people don't realize that I made a statistic. It was a statistic that showed up out of the United Nations. That's right. 380,000 villages are basically off the map. They're off of Google Map. They don't even exist. If you go and you zoom up Google Map, you keep zooming in and you just see land. You have no concept. Well, Google Maps wants to measure sidewalks and streets and buildings. Well, they don't really want to measure dirt roads or pathways, or they don't want to measure rivers or huts or anything like that. What's interesting is that imagine the amount of people that live in these things. 3.8 billion people out there. It's a lot of people. And they're thinking it's going to increase by another 404 million, I show by 2050. But we think it's going to peak and then maybe decrease. People are just not going to want to go there. So I want to talk about having villages become more of smart villages. We need them. We need smart villages. We need smart villages where we can understand the world around us, where we can understand the shifting climates, where we can understand the coastlines and how they change. And we could find ways to maximize this lost revenue and this lost sense of education that are kind of going in there. And even more so, to kind of reduce the amount of exploitation, because without all this information, someone comes walking in, their hands are wide open, and they get a set of beads from Manhattan Island. And I think this is really, really important. And I think this is something that we really think about. And computers and stuff from 1956, and we're 2017, and we still have empty villages that are not known. I think we need to talk about this. So, KUYAOYAO, it's located at that red dot. Now kind of zoom in, and you'll see Manila is the big red dot over by the left there. And those two other big red dots are the two other supporting villages, and KUYAOYAO is the little one. And notice that that part of the map just doesn't have anything on there. You keep zooming in, and you get something there. Well, why is there something there? Because I put it there. I did it. If it 2 months ago, that would have looked nothing. I came in there and walked around and looked with us. It's my stuff. And this information kind of breaks out where the fish ponds are and where this kind of haphazard land and all these squatters are sitting around on. And it's just a free-for-all. And you can even see there's offshore fishing. And there's significant population too. Google Earth doesn't show them. You're gonna go. You might catch it on some of the close-up images sometimes, but you don't always. And so these are the different kinds of maps that exist. Esri. Who gets Esri World? Nobody gets Esri. Esri's kind of. You get Esri. Good for you. So Esri it's a big kind of periodical magazine. You get it for free. It's a wonderful magazine because what it does is it really talks about this geofencing stuff that we all really want to know about. It talks about really taking this bits of information and doing so. But if you also notice, they're kind of focused on basically cultural areas, and though they're looking at third world stuff, they're actually seeing it. There's terrain maps, and there's landscape maps, and there's Mapbox satellite. It just goes a little bit on here. I drew this in here as well. This is actually living on open maps. I actually go in there and edit. Those are little trails. You can actually go in there and do it by looking at the map. You could go there looking at a Potch data material and get a detailed map. You could also wear a device in your backpack, hike around, the device just goes off and starts kicking off the trails, measures elevations, and so this information, of course, goes to some point where it actually gets picked up and then gets analyzed and then drawn on a map. But these sort of things need to kind of happen. Eventually, with enough information, of course, you get the different kinds of issues where you can kind of make a beautiful, all of us have been on, all of us have looked at beautiful maps created by graphics and the colors, the depths, and showing what grows at different elevations and where water might flow. And it also shows trails and property lines. And this rich data is essential. And I think if the villagers don't want this or can't use it or are afraid of it, then at least some district location should be very, very interested in this. And little by little, they're starting to smarten up, but I think there's a lot of room to make it a lot better. Evacuation centers, I'm kind of advocating that every one of these 380,000 villages have an evacuation center. There's a lot of things that are going on in this earth that maybe we really need to think about how to save 4.4 billion people in the world and really what to do with them, because they're very vulnerable. They're vulnerable to disease. Disease is a big issue. It's another whole thing on that. Could you make an IoT to measure disease? I think it would be kind of cool. I also talk about a community accountability response, medical records, library stuff. I also talk about radio towers and active data that might be collected on a yearly or monthly basis. And maybe this brings up something like smart villages. Maybe this brings up, this architect viewed this idea of like having these buildings slapped up. And I saw this other thing, my friend architect from Brazil, she sent me this whole thing where these cool houses on cars could be unfolded, and then you'd have a building, and then when you're all done, you fold it back up, and it's kind of makes a lot of sense because you see a storm coming. Maybe that's a good way to save your building. Just fold it back up and kind of hide it under something. Maybe that's a solution. It's a solution we're sitting on. Dive kiosks. I mean, the oceans are interesting. We've got radioactive materials in the waters right now. They're absolutely serious. Maybe we should start having information that's available to these people, like when it might be a bad day to go fishing. I mean, tell us, what's dangerous. And I think it's a really key thing to think about. So one thing that I found really interesting is that I came across a business located in Canada called the Water Ambassadors of Canada. So one of the big problems that a lot of these villages had at the beginning of my discussion, I was just like, what do you get? Water. So basic. You dig a hole and you get some water maybe. But what they found is like, geez, these wells go dry in the summer, and there's only 2 wells in an entire village. So these guys thought, well, the cheapest thing to do is to dig the well. The expensive thing is the pump. So thinking out of the box, you take the pump and you move it from well to well, little handheld pump, and you find wells that IoT might tell you this well over that way might give you some water, and that one won't, and that one over there will. And you can be guaranteed that you'd have some real live material evidence. And this is like a real life situation. And the same things would be in terms of like distilleries that we could set up. I mean, I talked to a guy named Bloom. David Bloom and I are really good friends. He and Buckminster Fuller 20 years ago, 40 years ago, maybe it's older than that, 40 years ago, he and Buckminster Fuller used to hang out and sit there and talk about like the whole idea of distilleries. And he showed me, we walked around, he showed me his plant out there in Watsonville. He showed me his plant, and so like, he's taking CO2, pumping it back near the plants. Plants love this stuff. They grow like weeds. It's got the sugar cane twice as high as it's supposed to be. He's got like things growing he's got things not seasonally, but 5 times a year, 6 times a year. He's got a great yield. This is a cool idea. This is to turn around this stuff. And we're talking about this a little bit. And then, of course, some of the GPS devices tell us what's going on. And I'd like to see the coral reefs being brought back up. Maybe we can figure out a way to do that, too, as well. So this information, we can kind of see that, this information can be put into something where we're using these systems that are just lightning fast and giving us a lot of information. Of course, we got this unfortunate issue with how it's being delivered, but once it gets from where it needs to go to where it actually arrives is actually fantastic. And if we can gap the two, boy, we got to maybe we can bring this information. And instead of like long hours and or days to receive information, we can get something more on the fly. So something like Maybe there's some kind of pollution, some kind of oil spill, or some kind of garbage spill that's coming around, and this information could tell them, like, oh my gosh, there's a weird methane glob coming down you, and this thing could show up. So I'm really about someone who can understand and play with these very complex thoughts, and it's kind of critical. They're complex, but just they're not easy. I mean, sit down, you look at all these programs, like go on some of these websites and try to build some of this stuff. It's to code this stuff. It takes time. You got to sit down and do it. You got to think about what you're writing out. You got to think about why, and you go through all of that, and then you get a little bit of data. But little by little, we could start thinking in our minds how we can actually use this for our practical aspects. I think it's going to be absolutely key and critical to all of us. I think it'll benefit every one of us in the long run. Here's an example, and no one's brought that up today, was the whole idea of augmented reality. And this young lady is using an iPad. She's basically focusing on some place. I think this has to be Italy. I'm always trying to remember where this image was, but I didn't take this one. And she's showing like how this field would look, that much better with this augmented reality information. And maybe this information would be something that you'd be able to see and use. Chatting, live videos, materials, work on change orders, work on artificial intelligence. Maybe the robot could display something. I don't know, working on something like that. So now we're trying to take something where we take these invisible populations and we kind of make them visible. We give them an improvement for standard of living. We might give some VCs a reason to invest in this. We might maximize our earth resources. We might reduce our waste around us. We might make our earth a better place. And so I'm here today to ask all of you to not only maybe think about being involved, but to tell others to be involved and tell them to be involved. And that as a larger group, that we might be able to help these, horribly, severely overwhelmed .org organizations. I mean, I talk to them. They're .orgs, oh my gosh, they're just like dime a dozen. There's a whole bunch of them. They're just like, nobody's listening. Nobody's giving us any money. Well, maybe they don't give it, But maybe we could think about something together as a collective. Maybe we can support them. Maybe we can support student research. Maybe we can support experimental student research or exchange, something like that. So I kind of have a challenge that right now, I'm thinking about by 2018, which is just around the corner, we've kind of built some kind of awareness. By 2020, we make some kind of action. But by 2022, we have a new process, a next process, that we don't just stop. It just becomes the next process where we can build on there a little further. So I have some wonderful references. I'm here to I got I've got a group of really cool people that I dealt with. I'm happy to help all of you. So if there's any questions, I'm here and I'd be happy to answer them. Yeah, there's.
I've got the drone project, but I've got something else that's completely violent. Like I did latex as a residence for 6, 7, 8 years. Now I'm playing around with artificial photosynthesis, and I found a professor in France who's playing around with the same thing. And finding grant money doesn't show up in the NIH.
So the question is, are there organizations out there that he could tap into, that look into? I mean, I have used Google, and I have sat on the phone, and I've gone to local commerce offices to different cities. I've been to cultural centers. I've been to potlucks. The potlucks are great because you get to eat all you want. They hang out with you. You show up at weddings they're kind of wonderful people that help you out. But yes.
There was a, I guess back in the sixties and the seventies, there was what was called middle technology, because I needed to build a tractor. And the guys in England figured out, well, I can build a tractor for $800.
Mm.
We can do a whole list of things.
Mm.
A tractor. I think that became renamed as a probate technology. And that seems to follow in this.
So the question also is, like, some of these other innovative thinkers that come up with ideas to kind of make projects that are out there, and his tractor example is a perfect one, and I know that Caterpillar has done pretty much the same sort of thing. There's stuff out there. Absolutely.
Another contact would be Neil Gershon fellow at MIT, who basically shows you how to, that's putting production in the hands of people. Extruding small machine parts, bicycles.
Mm-hmm.
He gives lectures on this and how to set that up using very inexpensive techniques.
Excellent. All right.
But he's a very good friend.
Well, any more questions? Any thoughts? Ideas? I can be reached. Amy Robotics is a company I work for. I'm their VP operations for him. If you want an operation, you want a cool robot to test your big data on, definitely look me up. I'm there on their website. You can find me. And enhance the village, of course. If you guys want to think about something like that, I'm all for that. Okay. Thank you.